There are many applications for logarithms in science and engineering. One of them that pops up in electronics is the concept of gain. And in particular, when we're dealing with an amplifier, the power gain is an important consideration. There's also voltage gain, current gain. We're not going to look at those. We'll only be concerned with the power gain. And if it's understood that we're talking about power gain, then gain is calculated by taking the ratio of the output power to the input power and then taking the common logarithm and multiplying by 10. Okay? And when the calculation is done in this way, then the units are known as decibels. Gain is commonly abbreviated by the letter A. We can't use G because that means conductance in electronics. And because there's several kinds of gain, usually the subscript P is also included. Okay, so here's the formula. AP equals 10 times the common log of P out divided by P in. And of course, P out and P in must be measured in the same units, either watts or milliwatts, whatever it is. Okay, so for example, an amplifier has input power 10 milliwatts and output power 20 watts. Find the gain. Okay, so we have AP is equal to 10 log P out divided by P in. All we have to do is plug in, but there is just one little thing we have to watch out for, and that is because the units of the input power and the output power are not the same. Okay, so in this case we have AP is equal to 10 times the log of 20 divided by 10 times 10 to the negative 3. Okay, so of course we're going to use our calculator to do the log calculation. 20 divided by 10 e negative 3. Okay, that's the ratio. Output power to input power has ratio 2000. Okay, now we take the log of that, and we get 3.3, and then finally multiply by 10 to get our answer in decibels. And that's where we come up with the answer of 33 decibels. Now, of course, we could rearrange this formula if we need to calculate the output power or the input power. So, for example, we have an amplifier given with gain 46 decibels, and we're given an input power 1.6 milliwatts, and we need to find the output power. Okay, so substituting in what we know, 46 equals 10 times the log P out over P in. Okay, so the first thing we're going to do after plugging in the numbers is divide by 10. That goes 4.6 equals log P out over P in. And then we want to rewrite this in exponential form. Okay, so again, the base is 10 because we have no subscript here. It's understood to be 10. We find the exponent on the other side. So that means we have 10 raised to the 4.6 power equals P out over P in. Now P in is given, 1.6 milliwatts. So we calculate 10 to the 4.6 power, 39,800, multiplied by the 0.0016, which is the input power in watts, and we get the output power of 64 watts. Okay, one more example. This time we're given the output power and the gain, and we need to find the input power. Okay, so again we substitute in the gain and divide by 10. That gives us 2.9 equals log P out over Pn. And then rewrite in exponential form. So 10 to the 2.9 equals the ratio of P out over Pn. And then substituting in the P out, 25 watts, we can solve for Pn, which is 10 to the 2.9, 794. And we divide 25 by 794, we get 31 milliwatts.